And so here we have another example. This time it's for another exoplanet called Kepler 10c, which is the second planet of the Kepler 10 star system. And according to the data that's published online, this planet has a mass that is 7.37 times the mass of the Earth. And so we did 7.37 multiplied by 5.942 times 10 to the 24th. And just to refresh your memories, here's my calculator. So that would be 7.37 times 5.942 exp 24, and we get 4.379 times 10 to the 25th. Now the radius is published as being 2.35 times the radius of the Earth, and as you recall, the radius of the Earth was 6.356 times 10 to the 6th. So let's multiply that out. 2.35 times 6.356 exp 6 equals, and we get 14,936,600. So I've converted that into scientific notation, and I did that by moving the decimal point, which occurs at the end of the number, and moved it over 1, 2, 3, 4, 5, 6, 7 places. And that's where we get the 10 to the 7th from. And then we rounded it off to 494. And we round that last digit to a 4 because there's a 6 that comes after the 3. And whenever that number that comes after is 5, 6, 7, 8, or 9, we can round that digit up. Now our formula is G equals the acceleration due to gravity, G, lowercase g, is equal to capital G times capital M over r squared. And capital G was 6.67 times 10 to the negative 11. The mass of this planet we just calculated as 4.379 times 10 to the 25th power. And then the radius of the planet is 1.494 times 10 to the 7th, but we're going to square that. So let's go ahead and do this calculation. We're going to start with the radius in the denominator, and we'll say 1.494 exp 7 squared. And then since it's in the denominator, we want to reciprocate it. So we're going to do the reciprocal key, shift 1 over x. Then we'll multiply that by the gravitational constant, 6.67 exp negative 11. And then we'll multiply that by 4.379 exp 25. And the end result we get is 13.085, we can round that off to 13.09 meters per second squared. So that would be the acceleration due to gravity on this other exoplanet. Kepler 10c apparently is, well, it's 7 times the mass of the Earth, and the information available online says that it is composed of volatiles, which means that most likely it has a lot of methane and ammonia, possibly liquefied, right, and other compounds that are volatile in the sense that they turn into gases pretty easily and they can burn, possibly. Okay, and then the radius of that planet is over 2 times the size of the Earth's radius. But if you recall, if we compare that to the radius of the other Kepler exoplanet, it was almost 1.5 times the radius of the Earth. So there's some interplay here. The 10c is more massive, but it also has a larger radius, and that explains in part why the acceleration due to gravity on Kepler 10c is less than the acceleration due to gravity on Kepler 10b. It's very fascinating stuff. We'll come back with some more consequences of these measurements later.